Right, just a quick repair. Bose Model 5 Music Center, one of these things. Turn it over that way. That's what that is. And YouTuber says display not working. VFD, vacuum fluorescent display. Then they've got heater wires, they've got anode voltages, they've got little voltage generators, they've got all sorts of things, and they usually go dim anyway, so sometimes they just fade away because of just general denigration in performance. However, having said that, to get this open, I just managed to get it open. Use the screw. There's a screw in this point here, and a screw in this point here, and then you can see these clips here. These clips engage in those holes. So after you remove the screws, you need to push in those holes whilst pulling on here, and then disengage those 3 clips. Then pull it forward, and then you can find that. There you go. So unhandily, the customer hasn't sent the power supplies in, but note that these run on AC and they won't work on DC. So you've got a 12 volt AC supply in, and the reason that is the way they derive the power for the VFD, the vacuum fluorescent display. So here's the VFD down here, and yeah, it's very, very dusty and dirty, as they always are. Let's just take that off for now and see a bit better. There's no signs of life, and I've checked the voltage on there, and they're a bit low. So in the display are some heater wires, and you have to apply a few volts across those to get them warm, so they emit the electrons, which can then go and bombard the anode and make them fluoresce under the control of the micro. So it's a digital display, but it works like more like a triode, actually, a thermionic triode. It's got heated wires, and these, you know, for a designer point of view, making a power supply for the VFD is a pain in the arse. You know, LCD, you just run them off the 5 volts or the 3 volt rail, but with VFD they have specific voltage requirements. There's no spec on this display. It's got a type number on it, but it's a custom Bose part number on there, on this thing, on the corner there. Look, let me get that over there. You can just see it, CR1337G. Anyway, there's no trace of that, but it works on the same principles. Okay. Now I've just looked in here. There's no schematic for this, but this is going to need a power supply. Obviously all the logic and everything else is coming through here, and this is the supply ribbon as far as I can make out. I've had a quick look, and there's a few hefty tracks coming from this part of the board, right down here into this area. There's a couple of diodes. Now bear in mind, you need to get a lower, fairly high current voltage. You could do it with a lossy regulator, or you could bodge it because it's AC. You can do voltage doubling. You can also do capacitive dropping of the voltages to get the level you want. And look, the tracks for this display, which come up through here to there, come all the way down into this area. Okay, so I think this is the VFD power supply section. Actually, it looks like it's lit up. It isn't. That's just the actual anode. You can see it glows green when it's working, so it's not working. Yeah, and anyway, so 2 diodes, they're not blown. That diode's not blown. Well, I'm assuming they're not blown. So which leaves probably, you know, the age of this product, I don't know if it's 10 or 15 years old. But electrolytic capacitors, high currents going through them, fairly old, is not a good combination, and this will be sensitive. If this voltage drops on here across the heater wires, or the anode's too low, then it just won't light up, and it can be between 50 and 40 volts. It's difficult to know without the specification of the display. Okay, so what I'm going to do is I'm going to probably take this board off, remove the CD tray. Yeah, so I'll work out how to remove the CD tray, and I'll come back to you. Yeah, the CD tray is very easy to take off. Actually, there's 2 screws which go in through there into the underside. You take those screws out, and then these clips on the back of here, these ones, they are engaged in those holes there. So you need to push them back gently, and then the top just comes off very easily. Actually, no problem at all. So that's an easy disassembly step. Now what we need to do is to, not sure where that came from though. Kind of a sprung-loaded buffer stop. We'll find out where that goes in a minute, won't we? Bloody typical when you open a Bose, something bloody falls out. It might just be a spring-loaded thing to make the lid spring up. We'll find out. We'll find out when we put it back. But it's typical. All the piece of crap falls out the Bose when you open it up. Okay, so to take this controller out of here, that's a ribbon cable. Make sure she's unplugged. Pull that ribbon cable out. Gently ease out that one. Ease out that one. And take the power plug out, which is this one. Might use a lever for that actually. It's obviously better just to do it in a controlled way. And then another further plug across the front here, in the front corner. So that should allow the display board to be removed by judiciously fiddling with all these clips along the front. Well, actually not on the front, on the back. So one there, one there, one over here, this one, and some others somewhere, I expect. I can feel them, but I can't see them. Oh, there's one there. And then your display. Oh, there's one more connector. Yeah, another connector on this corner we've forgotten. He's screaming at the screen at me. Right, so that's the display board. Any clues on the back of this where these supply tracks go? No, not really. Right, so let's put that over there out of the way, and then let's try and get this board out. So is that a connector? No, that's not a connector, that's actually a wire board header, so that connector will not come out. So we're left with just trying to remove this board somehow. Again, it looks like clips along the front here, pushing the clip in there, pushing the clip in here. It feels like it's screwed down. Oh no, there's a clip here as well in the middle. Let's put some clips in, boys. I reckon that one bloke at Bose's job must be just to design the clips. Right, so we've got the wire stuck in here, and it's stuck in with this fairly unkind cable guy, which we've got to try and get these wires over the top of that. And get them out one at a time, I should think. Of course, one wire is shorter than the rest, as you'd expect. It's this IR sensor in the corner, which is the termination of those wires. I'm in a hurry, you can tell, can't you? It's been really busy this week. And this is for love of the planet. Okay, so now we've got those out of the way, we can get some degrees of freedom, or at least some freedom with this board. Now we're looking for more clips. So hold on. All these sockets through the back, I think you're going to have to force them forward slightly to get it to come out, perhaps. There we are. So here's our controller board free. And what we've got on here, we've got a whole row of horrible electrolytics. If this was my own product, or my own thing that I was fond of, I would spend an hour just changing all of those electrolytics. Because, you know, if you look on the data sheet for most electrolytics, for example this one, if I look up the spec for it, it's only an 85-degree one for a start. It's not getting very hot in there, and you know, most of the data sheets for these are at the maximum full chat, i.e. current and temperature, rated for 1,000 or 2,000 hours operation. That's all before they start to drift out of value, because they dry out. And on VFD displays, the capacitive supplies are taking quite a lot of the capacitors in the supply for the VFD. Usually take quite a bit current because they use them as droppers. Okay, so what I think I'll do is to whip out some of these caps, just look at them, and then try and sketch out the schematic of this thing to see how it works. I haven't got much time, but it'd be interesting to see what they are and why these capacitors on this board are the ones that have failed. And I think the answer to that one, we've already answered that, is the amount of current flowing through them. AC current. They're being used in the AC mode usually, So that's the first thing you would do. If you see a VFD board, you would trace back to where the power comes from, look for any burnt out components, check the diodes, and then change the caps. And then you'll probably find that there's they've drifted out down to oblivion almost. Let's just turn the soldering iron on. Move my video camera out the way. Right. So these are the down in this corner. Can't see which one. I don't know which one's the dropper at the moment. You can see there's associated diodes with it, and you can do voltage doubling and rectification, stuff like that. There is a diode to is that 0 volts? Going to stick this on the tuner can, one probe. Yeah, so the top of that diode is positive, so it's probably going to be a negative supply for one of the electrodes in the VFD display. If you want to look up VFD display, you can see them all online. I'm really just showing you how to fix this thing. I don't know whether I'm going to be successful. Yeah, let's just whip those caps out and just check them. They're going to be in the firing line. There's no point trying to work out what's going on because I don't have the schematic, otherwise I'd show you. But while I take them out, I'll see if I can work out what the schematic is. And then we can probably see then what's going on, can't we? Yes, we can. Right, so let's whip them out. Without further ado, start off with C12. Remembering the positive side is this track at the edge of the board. Very handy actually doing this. If I forget which way when you're making a video, you can just zoom back along the video you've taken, providing you remember to press the record key and have a look, see what you've got. So what we've got here is a Nichicon, which is a good capacitor, 25 volt, 100 microfarad Nichicon. Now I'd expect this to be pretty good if it's Nichicon, but if it's been mistreated, then we've got a problem. So we're on auto ranging capacitive range on the old DM100C, shall I say. Very good meter for the price. It's amazing. Right, so you can see that. Let's see if I can hook onto those without spilling beans. That doesn't look right, does it? That's 100 microfarad, please. Can I have 100 microfarads? Sure, what I was doing wrong there. $67, $63. So the 100 microfarad. When's the 100 microfarad capacitor not on 100 microfarad? When it's 56 microfarad. So that one's you know, it could have been a minus 20% to start with, so it might have dropped 20% at least. Okay. So that one is the 100 microfarad one, 25 volts. So that needs changing. I have no idea if this will fix the problem, but it's the area I would automatically, straightforwardly go and look at on one of these. Let's have a look at this one. Which other one's the other one? This one here, I did measure it, has got the 12 volts AC going in on this side. So this is one of the power supply capacitors for the dropping circuit. Okay, so she goes in the same way around. I always try and design my boards with the caps all going the same way around. So this one is a 33 microfarad. You see that? 63 volt. 63 volts. I was expecting some voltage on there. It's 12 volts AC, isn't it? So maybe this is part of the doubler circuit. Who knows? Who can say? And another Nichicon, so it's a good make, good Japanese make. 10 microfarad, right? So that one has gone from 33 to 10. C17. Not good, is it? it's not good. What about the other two? These aren't on the AC drive side, so I don't suppose these ones are blown up, do you? Who can say? Positive side on this side again. It's just on one leg this time. One. Okay, so there's two more out. So we've got 100 and a 220 there, so let's see what they are. Yes, please. No, I don't want dog sausage, thank you very much.
She's going to hide again. Don't you go.
So that one's fine. 103, I think. Yeah, that's supposed to be 100, 103. And this one's 220. Just get some clips to put on here, shouldn't I? Just try this one. $244, right. Okay, so it's those two Johnnies. These two have been taking the brunt of the current carrying job for the VFD, and they've gone way down in value. And if they go down in value, they won't be passing as much current because it's an AC circuit, don't forget. They look, those two little ones look to be in series with each other with a diode network. So that's a doubler, is it? Okay, I'll just sketch out this schematic. Yeah, I've quickly banged out the schematic for this power supply circuit. It's very simple. 12 volts AC. That transformer is not inside the unit. It's that's effectively connected by a DC jack, or a power jack, shall I say, not DC in this case. One of the wires goes bonded straight to the 0 volt chassis. The other goes through C12, which is supposed to be 100 microfarads, 25 volts, but it's actually reading 60. It's dropped to 60, and when the this line sweeps positive through the positive part of the cycle, this capacitor charges up through this diode. When this sweeps down again, the voltage across it is then pushed down below the 0 volts, and this diode conducts, again charging this capacitor here, which is a reservoir capacitor for the minus 30-ish volt supply, C15. You can see the positive end of this capacitor is connected to 0 volts. Okay, so it's a negative supply. Then there's a resistor divider network with a further reservoir capacitor. Remember, these two were okay, and another negative supply for the VFD. It's a biasing supply for one of the plates, I expect. And then the main one as well, this at 33 microfarad had seriously reduced about 30% of its correct value. And this is simply an impedance, which is designed to be basically a lossless impedance of roughly, obviously it's a completely reactive impedance, but if you can imagine, if you can imagine a load of the heater filaments down to 0 volts, they're actually down between here and 0 volts, then you've got effectively a 90 ohm path to heat the cathode heater supplies, so you don't get a lot of losses from this supply. So it's a reactive, perfect capacitor with completely lossless voltage dropper, and that has now dropped to 10 microfarads or whatever it was. So there's very little current. The current that's going through the cathode heater is much, much too low to make it emit. So I'm thinking we need to change this cap and change this cap, and then we'll try it out and see whether the display comes back on. I think it will. I've fixed enough VFD type products in the past. So that's a rough schematic of the power supply, and that's how it works. So that's the capacitor, 33 microfarads, 63 volt. And there's the Farnell order number, 2342310. Here's the cap for C17. I've got a nice new Rubicon, about the best you can get. Just going to put that in there. Solder those two back in. Make sure it's the right way around. I'm going to resolder those ones I took out. They're okay. If you haven't got a capacitance meter, then change all four is my advice. Right, I've got to find a 100 microfarad 25 volt one. That's the only one I've got left to find. I should find one somewhere. Got a brand new one's been tapped into this power supply, which is awaiting repair. I'll just pinch it. There we are. So let's put this one in. This one's for the bias supply, C12. Goes in that way around. Lightning here at the moment, so if I have to go quickly, if I disappear quickly, or there's a big flash, it's not my electronics. I've been struck by lightning. Actually, my sister's house has just been struck by lightning. I'll stick a picture up of the fuse box, but she's okay. Nothing's working, but she's okay. Right, so that's all the caps back in. So I shall put the chassis back together and plug all the plugs back in, and then I'll resume when we can give it a go. Okay, she's all back together. You can see I just put her in the light. There we go. She's all back together. All the plugs are back in, and check that. Everything's checked. Everything's fine. We've got 12 volts AC on the Z plug here. 12 volts AC on that. One thing I got to mention, if the display is a bit too dim and it's getting old, you can reduce the value of C17 slides, make the wires get a bit hotter and make the display a bit brighter as well. So you can, when this is aging, you can compensate a little bit by, say, instead of putting a 33 in there, put a 47 in, and that will cause more current in the heater wires and make them hotter and emit better, and you might just get several years more life out of your display if it's not bright enough. Okay, so let's just try this. I'll turn the lights off so you can see, because it's very bright, these lights. Let's just plug her in and see what happens. Power going in now. If I can find the hill. Right, I heard the CD reset then, so if we hit one of those buttons, there you go, it's working. Nice and bright actually. Yeah, so we got display working again. It was those two capacitors were undervalued. So yeah, I'm not going to bore you by putting the whole thing back together, but yeah, so look at those caps down there in that location as I showed you, and the chances are that it'll fix your unit if the display is very, very dim or disappeared altogether. Okay, so yeah, that's a fix. So thanks for watching, and if you have a moment or two, subscribe to the box down there and leave me a like. I'd appreciate that, and I hope you found it interesting. If you're repairing your unit, well, good luck.